And we are good to go. All right, hello everyone. Welcome back. We're doing this this live stream / meeting / webinar type thing to help small businesses, independent site owners, basically anyone who runs anything online, to try and get them to understand how to save some money during this crazy time by mitigating, detecting abuse, fraud, whatever else. Last week, we did a similar live stream on how to detect fraud and abuse, talking about the types of data to look for and some strategies around that. This session, we're going to be talking about how to actually mitigate that. So with me, I've got Tafara Mwandi and Metodi Dinolov. Tafara, you want to give a few sentences on who you are?
Cool. Thanks a lot, Jared. So like you said, my name's Tafara. I'm the Director for Threat Analytics and Reporting at Shape. Been with Shape close to 4 years now. My job mainly focuses on analyzing sophisticated threat actors and looking at sort of, how they retool and sort of some of the strategies that they use.
Cool. Metodi.
Everybody, I manage a internal team for Shape / F5 now. We deal with the actual bot mitigation. So any kind of bot that is not automatically blocked by our system, we're going to write specific rules or change the way things are configured in order to be able to mitigate it in real time.
Cool, thank you. And just like last time, I'm still Jared Overson. I've been with Shape for about 6 years and have mitigated a lot of abuse. So we talk about, at Shape, we talk about mitigating massive scale abuse. In these streams, we're talking about very, very small, low levels of abuse. So it's going to be different strategies, different mitigation durability. But we'll get into those. And before we do, I guess set the stage, how have you guys been dealing with this coronavirus pandemic and social distancing in general? What does your life look like, and how has it changed?
Well, for me, spend most of my time indoors. My wife is also working from home, and we've got a family member visiting. So it's just the three of us in the house. Stay indoors most days, only going out like maybe twice a week, either for groceries or for like a walk. Yeah. Other than that, lots of TV has been sort of the trick.
What about you, Metodi?
It's much easier to be stuck at home without kids. Our daughter just turned 2 years old very recently, and it's kind of hard to coordinate. Who's going to be taking care of who, and I have lots of family in the area that I live in, so it's been tough not being able to visit them. But we've been isolating, or not isolating, but staying away from people since about March 2nd. So we haven't seen anybody really other than ourselves since March 2nd. So
yeah, we're inside a lot as well. I've got 3 kids and my wife at home now, and it is hard. I feel like most of my day-to-day is trying to stay sane myself and keep the kids as happy as possible to minimize the overall traumatization of this event. And it's hard when like other kids are in their backyards and they can't just like readily play with each other all day. Like it's strange and sad. And I go out regularly as well. Well, much less regularly than normal, but I'm the person who often goes out to stores. And it's just sad seeing everything that's closed down. And I wish that I could personally help more of the small brick and mortar type shops, aside from just paying for takeout whenever I can. But I mean, if we can help some small internet focused companies, then I guess that's It's a little bit, but it's what I can offer. So jumping into mitigation. So like I was saying before, we generally do massive scale abuse mitigation at Shape, and the strategies for that are wildly different than dealing with low level abuse at smaller companies because it's a cost versus value risk benefit game with attackers. Where if you are a massive company with a lot of value and abusing that company nets an attacker a lot of money, then they will try many different elaborate and sophisticated means to get that abuse. With smaller companies, because the value is so much lower, attackers aren't going to be trying the costly, sophisticated, elaborate schemes just because the cost versus value isn't there. So the stuff that we're going to be talking about today are the types of mitigations that are appropriate for small level abuse, because all you need to do is raise the cost of attacks just a little bit so that attackers targeting you just no longer get the value they were getting out and they move on to somebody else. And this is a persistent theme in everything that we talk about when it comes to fraud and abuse mitigation. Is tweaking the balance of the cost versus value so that you just make it financially unattractive for attackers to continue attacking you. Just to clarify one thing, I use the word attack and attackers a lot when I talk about this stuff because when you're dealing with massive, large-scale global attacks, or global abuse, it feels like a very deliberately aggressive behavior from a group of individuals, and that feels like an attack. For smaller companies with low-level abuse, it might not feel like an attack. It might just feel like you are being annoyed by some jerk on the internet somewhere. So don't think that you have to have something that feels like you are being deliberately targeted by some aggressive adversary. Abuse might just be some jerk who found a way to drain your resources, take over your accounts, or whatever else. So don't let my using the word of attack and attacker dissuade you from looking more into this more deeply. So what we're going to be talking about right now on this stream is a lot of mitigations based off of network metadata, stuff like IPs, other stuff that we'll get into. And then if we have time, we'll talk about CAPTCHAs, where they work, where they don't, what's good, what's bad, and we'll go from there. So Metodi, you are probably the person who is most familiar with IP addresses as a form of mitigation. Do you want to just ramble a little bit on IP addresses, rate limits, and whatever else you can use for mitigating abuse?
Yeah, sure. It's Tafara has a lot of domain expertise there as well. So feel free to jump in at any time, Tafara. So, IPs are a funny thing. IPv4 space, I assume everyone here is familiar with IPv6 versus 4, is super overcrowded. There's lots of natting going on. It's kind of difficult to limit the number of transactions when you're talking about one or two transactions. But what is super effective is avoiding times when there's a burst of activity in a very short amount of time, right? So you don't want to be blocking IP addresses for blacklisting them, right? You want to be able to do things like, over a minute time span, 5 minutes, 10 minutes, very effective way of preventing somebody from just blatantly using, a million requests from a single IP address in an hour, which is possible and something that we've seen before, right? So there's lots of ways of doing this depending on how your stuff is set up. what kind of load balancer you're using, if you're using a load balancer, who's you're doing your web hosting. But you know, a lot of the web servers, web services out there will allow you to set up IP rate limits, right? And some will even have multiple options, like, you know, for for a set number of requests, the types of requests, web requests there are, the duration, whether you want to slow down the responses and queue them and cache them. So this is all assuming that there's some sort of provider with DDoS protection, right? This isn't going to protect you against, like, you know, SYN attacks and floods, things like that.
You know what? I think we made an assumption at the start that I want to roll back on, because the people who might be jumping into the stream or finding it later somewhere else might be people who aren't even entirely familiar with the nuances of what an IP address actually is, let alone IPv4 or IPv6. So an IP address, I mean, it's very similar to just like a home address. It's the way that computers talk to each other across the internet. So when we talk about IP rate limiting, we're basically talking about limiting the amount of damage that can come from one of these addresses on the internet, one of these homes on the internet. Because if you can see that there is 1,000, 100,000, 1 million requests coming from one single network device on the internet, you can look at that and be pretty sure that that is not a legitimate user, and you just want to cut that off and limit the amount of damage that one individual network device can cause. So Tafara, do you, that sounds, for people who haven't actually jumped through the cat and mouse game with attackers, that might sound like actually a pretty effective mitigation. Tafara, could you talk a little bit about how attackers aren't stopped by that at all, and where the cost versus value balance lies when dealing with IP rate limits?
Sure. So I think thanks, Jared, for that explanation of sort of what an IP address is. But, you know, unlike a physical house where it's very expensive and time consuming for you to change your address and move to a different house, on the internet, it's pretty much a click of a button. Within a few seconds, you have a brand new address. So because of that, trying to cut off addresses is not a long-term sustainable solution, because it is pretty trivial for a person to go to the next address. So to Metodi's point, there's pretty much two strategies that people typically take with IP addresses. One is to rate limit and one is to blacklist. And I'll sort of quickly talk about what the difference is between those. So blacklisting, you're simply saying that this address is bad and I never want to see any transactions from that particular IP address. Rate limiting says that I do not want to see more than, you know, X number of transactions from any IP address within a 10-minute window. So what that then allows you to do is that even if this attacker changes their addresses and tries to send a large attack, because you did not specify which address you wanted to block, but you said any address that does a high volume of attacks, that then allows you to remain protected even if this attacker changes their address. But what that then encourages attackers to do is to use not one, but to use multiple. Sometimes we've seen hundreds, thousands, even millions of these IP addresses, so that they can stay below sort of those thresholds that you have set. But the advantage of that is that the more IP addresses that you force them to get, the more expensive it becomes. And especially in this segment of businesses that we're talking about, there's nothing, you know, really special about your website. You know, it's not something that you really want to hear, but there's lots of fungibility and there's lots of comparables. You have lots of competitors and other people that offer similar functionality on their web page to what you do. So what you're trying to do is you're trying to just be faster than sort of, you know, the last guy or the other person, to get 1,000 IP addresses, whereas if they go next door to someone else with a similar website, they can do it with one IP address at lower cost. That's sort of where that trade-off that Jared is coming into comes comes through, where they're now having to make the decision, is it worth it for me to invest in more IP addresses just to attack this website, or should I go next door to another website where I don't need to spend those kinds of resources?
And that's a very, very good description. And the differences in the types of abuse that we see at the higher end is that we are getting sophisticated developers who are programming their own tools to bypass defenses or to continue attacking. At the very, very low end, you frequently will not find independent, motivated developers attacking small businesses. What you'll find are people who attack common plugins or software or forums or endpoints, URLs, things like WordPress, bulletin boards, things that have a common format across all the implementations, so that they can use pre-made tools and then run an attack across tens, hundreds, or thousands of sites, find which sites are vulnerable, and then continue an attack from there. So what you can find is that you get a fair amount of protection by just having enough defenses that make your site look just different enough that an attacker is going to look at it and say, not worth my time to customize my attack for this site. I'll just go on to the hundreds of other sites I found that have no additional defenses. So the one step up from the, or down, I guess, depending which direction you're looking, from IP addresses are buckets of IP addresses that all come from similar regions or similar companies, because there are some types of addresses that you really don't ever need to worry about a lot of your users coming from. So if you think of like Amazon Web Services, Google Cloud, Azure, DigitalOcean, whatever cloud services out there, you can be fairly sure that a whole bunch of traffic coming from those are not legitimate users, because legitimate users will come from their home addresses. So Metodi, can you talk about ways that you can group or bucket these IP addresses to have kind of like blanket rate limits or blacklists?
Yes. So, there's a lot of metadata associated with a single IP address, which includes what I think you're talking about is the autonomous system number. The autonomous system number is something that the internet registrar gives an IP address. Like an IP address cannot be assigned to a person or an entity without being registered. And with that registration comes this number, which is an identifier of who this IP belongs to. And like you said, large organizations like AWS, Azure will have, millions, hundreds of millions sometimes of IP addresses assigned to them. And they have a specific number and also a canonical name, like a human readable name, so that you can distinguish, what organization or which part of the organization the IP belongs to. So usually data like that is sort of free to acquire and have assigned to the IP address. So what you can do is these ASNs, these names, can serve as a good guide or group to say, okay, so I don't want to see AWS hosted traffic on my service or website. I don't want to see traffic coming from Russia. I have 0 Russian clients. I do not ship to Russia. Nobody in Russia uses my service, right? Nobody in South America uses my service, or I don't anticipate it. So you can group these IPs and say, okay, all my customers are North American customers or European customers, and I want to make sure that I only accept traffic from those regions. Now that all these ASNs and names are pretty dynamic, so it's kind of cumbersome to keep that up to date. But certain things like your example, Jared, Google, AWS, DigitalOcean, any kind of hosting service will have, you know, kind of a stable 1 or 2 year cycle of having those names to stay the same. Now, here's a interesting trick. If you know, maybe not everybody knows, but all these things have to be registered. You don't necessarily have to pay for the data, but there's these things called broadcasts. And there's websites where you can look for the total ASN names, all the ASN names available, like Aaron.net, which is Aaron is the registrar that registers those IP addresses. And if you look for keywords like hosting or cloud in the name, you can get a pretty good list with very little effort to make as a kind of a blacklist or slow down requests from there, or put them in some sort of a rate limit. So yeah, that's one part of it. The other part is of the metadata is the location. All right. So depending on what kind of system you use, if you can get data for where these IPs are coming from geographically, we're not talking about zip codes or anything like that. We're talking about country codes, right? So each IP will have a country code, like which country it's coming from. So you can search for those or group them by those as well to kind of help you classify.
Well, Tafara, you want to add anything to that? Well,
Still muted, Tafara.
You're unmuted now.
Cool. Yeah. So I was going to add something with regards to sort of, what we call geo blocking. So geo blocking simply means that if your business is, resident in a particular part of the world, and you expect 100% of your customers to come from that part of the world, then you can pretty much do what they call geofencing, where you say that I only want customers from North America, or I only want customers from a particular country to be able to access my site, and then you can mitigate sort of outside of that. There's a bunch of problems with that approach. So some of the problems are that some of your legitimate users from your country might travel to a different part of the world. Because of COVID-19, luckily, the chances of that happening have sort of become, greatly reduced. There's also users, sort of both good and bad, who could use VPNs. The VPN would allow them to be able to pick an IP address from anywhere in the world. So that allows your local users who might be using a VPN to look like they're coming from outside your geographic area that you prefer, or the vice versa, where if attackers or fraudsters see that they can no longer access your site unless they get an IP from a particular country, then they would just spend the extra money on a VPN service to be able to appear like they're coming from that country. But remember what we said in terms of those costs. They keep adding up. If you're forcing them to have to get a VPN service, that is extra cost and an extra barrier that they might not be willing to sort of take on.
Yeah, that is a lot of good information there. And I think I want to tie this all back to the cost versus value. Again, low-level attackers. And I'm going to hesitate to use the word script kiddie, but that is a term that people know and have heard before. And it is good enough. But it's basically people who don't know how to write their own tools or even how to configure existing tools that are the easiest to block with these sorts of techniques. If you have a tool that specifically distributes itself or its traffic through something like Google Cloud or AWS, and you block all of Google Cloud or AWS, you have effectively nullified the effect of that tool against your website. And that can be all you need for months, even years of protection, unless you get an attacker that is deliberately targeting you because it's trivial to bypass for somebody who knows how to do it. So we constantly talk up and down with where these things fail and where these things are good. And want to reiterate one more point. This is very much something you're going to have to play with as a business owner to figure out what works. You're not going to get a silver bullet solution that says just do this and you're fine. You're going to have to understand how you're being abused and where that abuse is coming from and which mitigation techniques are more durable than others, so you can start to layer them on top of each other to make it more annoying for the attackers. It's hard for us to give exact advice on how to IP rate limit or how to block ASNs or how to do all this stuff, because so much of it is dependent on the service provider you're using. But at least knowing these terms gives you the ability to either talk to your representative about ASN blocking or ASN rate limiting, or search their docs, search their configuration settings, search whatever, so that you can start to understand the parts of the system that you might not have been playing with before. We're gonna talk about CAPTCHAs, but we're already about 30 minutes in, and that is probably a beast of a topic on its own. Let's finish this off with talking about HTTP headers and how they can be used to identify traffic that you probably don't want on your site. Metodi, you want to jump in on that one?
Yeah. I'll take one step back first. Sometimes people don't even know that they're being abused, right? You need to have visibility. A lot of what we're talking about here is not that complicated if you have the appropriate visibility. So you have to be logging your traffic, and you have to be keeping a decent amount of it, right? So knowing what to keep is an important step, right? So for the headers, the HTTP requests will provide some identification headers. Some of those might be added by service providers or web services. Let's say you're hosting your site on GCP or Amazon or GoDaddy. When the request comes in, and by the time it gets to where the website that your business is, there might be some things added to it. So knowing what those things are and what to keep and what comes from the internet or what comes from your provider is pretty important. So now this is not an industry secret or anything, but the order in which the HTTP headers are received by the server is important, because if you think about browsers, the browser you're using on your computer, and that does not change which order it sends these headers, which are important for your web server to know how to serve content to them. So attackers, in order to bypass some detection rules and some known ways of eliminating traffic, will change the order of these headers in the value of these headers. As you're seeing traffic come in, the order in which those headers are received is a very good indication of whether or not something is synthetic or not. Or if you're seeing, if you're looking at traffic and you see a user agent of Chrome 80 and it doesn't have accept encoding header, that's a pretty dead giveaway that somebody is just faking that request. And faking means they're either using curl or Postman or something like that to make a synthetic one. Tafara, I'm sure you have a more eloquent way of explaining some of this stuff.
Yeah, sure. So in terms of just, the headers, so if you're logging sort of the headers, the order in which they come, a lot of the tools that Gerard was talking about that are used to exploit whatever, platform that you're on, typically organize their headers in a particular way. So by looking at that header, you can be able to group all the transactions that are coming from that particular tool. So what then happens is, if, for example, you have tried the IP blocking, but they're using, hundreds or even thousands of IPs, you've tried to block, these hosting providers, but they're now using residential IP addresses from the country that you actually prefer. By looking at these headers, you're able to identify all the traffic that is coming from a given tool. So by blocking that series of header or that header order or that header pattern, you're able to mitigate not just that one actor, But any other actor who might come and try to use the exact same tool or the exact same attack framework against your site.
Yeah, this is something that it's kind of if you're not familiar exactly with what HTTP headers are and even how they differ across tools, this can be kind of hard to picture. I don't have any examples set up, so I can't stream anything, but I'll include some in the show notes afterward. But something like developer tools like Phantom.js, which was a popular headless browser about 4 or 5 years ago. Not very useful now, but it contains a specific header difference that is easy to talk about. So there's a host header that is sent in HTTP requests that basically tells the server, it's like, hey, this is the host I'm trying to reach. So something like google.com. And they send this because a server might actually have a whole bunch of hosts on it, and it needs to know which host you're asking for, so it can send you the right information back. Now, something like Chrome sends its host header first in an HTTP request. Phantom.js, on the other hand, sends it at the very, very end. So since Chrome is a much, much more popular browser used by legitimate users around the world, and Phantom.js is a developer tool generally used to automate testing on websites, if you're finding a lot of traffic that has some of these Phantom.js signals, then it becomes very easy to say, hey, no, Phantom.js, or at least traffic coming in that looks like Phantom.js, should not be allowed to interact with my site because it's such a low percentage of legitimate use that you just don't really need to worry about it. Now, actually looking at headers and trying to identify which headers and header orders are abusive on your site is going to be a pain, and I probably don't recommend it unless you start to get into the weeds and you like doing this stuff. There are sites out there that have a list of headers that either should be present or shouldn't be present on most legitimate traffic. And you can probably just assign basic blocks on things like that and do a decent job at blocking low-level naive tools from interacting with your site. Stuff like Metodi, you were saying, there's a whole bunch of accept headers, which a browser sends to say, like, hey, I'm accepting content in this language. I'm accepting content with this encoding. I'm accepting content in these formats. So the server can choose which one of these to send down for that browser. A lot of automation or attack tools don't send those by default unless explicitly set because they're just different sorts of tools. So you can block based off of the absence or presence of some of these things relatively easily, provided you have the tools with your service provider or your application software. I'll add a few of those links to the show notes afterward. Any final comments on this topic
Yes.
before we move on? Yeah.
Yeah. So one easy way to link problematic headers or a potential of making things easier for yourself is if there is somebody being really stupid using one IP address to conduct millions of transactions, thousands, depending on your traffic, it's high, it stands out. Looking at their order and comparing it to everybody else will immediately show you how they stack up, right? And instead of just blocking the IP and going for that is a much more effective way of mitigating the traffic. So, you don't have to know which header orders are bad or to know exactly how accept encoding is defined in the RFC. You have to say, this is bad. Let me look at the underlying traffic and see if these header orders are weird.
You bring up an excellent point. That'll probably be a good one to close on. Is visibility is critical. If you use a bit of data that is providing you visibility and use that data to block an attacker or abuser, then they are going to be, if they do want to continue attacking you, they're going to be incentivized to change the data that you are using to block them in order to get around your blocks, which is going to eliminate your visibility on the attack. So Metodi was talking about IPs blocking and rate limiting, and he proposed a potential scenario where you actually have great visibility on an attacker based off of lots of requests from a handful of IPs. It might be better to not block on an IP address because you can use that to have visibility, and you can use something like the header order to block or limit damage from that traffic, so that they don't try to move towards something like global proxies or anything else. So they try to get around to block a different way. So you retain visibility on the IP address or something else, so that you can see how they move through the system if they start to play a game back and forth with you. And this is what we get into a lot at Shape with long-term customers, is an evolution of these attacks and defenses, and figuring out which combinations work, which combinations give better visibility, and making sure certainly that we, number one priority, never lose visibility on abusers. All right, I think that's probably good enough. We definitely don't have time to jump into captures or anything like that. Tafara, Metodi, anything else that you want to add before we close out?
I don't know if we want to talk a bit about user agents and sort of, if those are suitable for blocking or not.
Yeah, sure. Yeah, so definitely on topic. And we can just close out the network metadata as part of this stream.
Cool, awesome. So the user agent string is also, similar to the header order. It is supplied by the browser so that the origin server knows what browser it is and sort of what's the best format to serve the web content in. There are certain browsers that are common, and you would know what those user agents look like. Some of the things that we have typically seen is that a lot of the attack tools, especially ones that are being used to attack older businesses, are much older tools that are now readily available for free to some of these, novice attackers. So a lot of them were built on top of very old browsers. So typically that tool will be claiming to be, for example, Chrome 31. Chrome 31 is over, 6, 7, 8 years old. There aren't that many legitimate users that are still using that version of Chrome or Internet Explorer 5, for example. But a lot of these attack tools were still written on top of those browsers and would still provide the user agents for those old browsers. So simply knowing the distribution of the user agents that you expect to see would be able to tell you the user agents that you don't expect to see, and you could successfully mitigate on those. There's also invalid user agents, where a user agent is not a legitimate user agent. There's a certain format and structure that you would expect to see of a valid user agent, and if a user agent does not have that format, that's also a telltale sign. Some of these attack tools, let's say, for example, some of the headless browsers, like headless Chrome, for example, it will say headless Chrome in the user agent. So that is some of the easy things that you can look at when you look at even some of the tools like curl or Postman. By default, some of these, automation tools will report in the user agent that this is the tool that is being used. So you can look for some of those in your logs and actually be able to mitigate those. We've also seen some attackers that don't send user agents at all, because they believe that that allows them to get around sort of user agent blocks and user agent rate limits. So that by itself is a signal. You expect every legitimate browser to supply a user agent. So if there's any transactions that are coming in without a user agent, that is a telltale sign in and of itself.
And if you use something like Apache, Nginx, or even just general software like WordPress, common stuff that people use to build sites and services, a lot of these have ready-made plugins to do a lot of these defenses without much work. It'll certainly take work to maintain these over time, but it's not an insurmountable amount of effort to Google some tutorials with the software that you have in your stack, along with like terms like blocking bots, IP rate limiting, ASN blocking, terms like that combined with Nginx or Apache or WordPress will give you pages upon pages of results for some things that might just be easy as a click away to integrate into your system. Metodi, anything else you want to add about user agents?
Spelling mistakes.
Yeah.
Okay. If you, let's say Chrome in the Chrome user agent isn't capitalized, that's not something that happens by accident, right? So it could be as simple as that. But again, if you don't have the visibility, you will never going to see it. It's all about the parallax view, because you need to be able to move around and kind of look at traffic in different ways in order to be able to pick those things out. So.
Well, thanks, Metodi. I think that's probably a good place to wrap it up now. So before we jump off, wanted to ask a human question of both of you. So what is one thing that you've started to learn how to do differently, or for the first time now that you've been stuck at home for weeks in a very, very unique experience? And to start, I've learned how to make sourdough starters recently, which is something that I've never prioritized doing ever in my life. But thanks to Twitter and a stream of people posting bubbling buckets of flour goop, I decided it was probably worth doing as a science experiment with the kids. So now I know how to make sourdough, which is something that is I can tie back to coronavirus for the rest of my life. Metodi?
Yeah, I've it's not different, but I love making stuff, cooking especially, and I've been taking over the kitchen every evening to make something different. Experimenting with different foods, ethnic foods. It's been a lot of fun for me. Regularly, I would never have this opportunity. My commute is very long and just don't have the time. But for the last month, every single night I've made something different. So it doesn't have to be complicated, just simple. So that's one thing that really enjoying differently.
What about you, Tafara?
I can't say that I've learned anything new, but I think I've had to, change up my routine. I usually cycle to the office, so that's usually how I get my exercise. But nowadays, I haven't been able to do that. Also being, I guess, more disciplined about eating and drinking lots of water. So, so I've got like a whole bunch of water. So I've been doing a lot of that as sort of a way to, if I can't increase the output of calories, I might as well, manage the input.
Cool. Thanks, guys. So I'm on social networks, Twitter, LinkedIn, YouTube. You guys can find me there if you want to ask questions. So I'm at JS Overson on Twitter. Feel free to direct message me or mention me with questions about this stuff or topics to address in the future. Leave comments on YouTube, wherever you can find me. Tafara and Metodi, I think you both are substantially less socially than me, but is there anything that you want to point people to, or do you want to just filter them through me?
I have no social media presence. So.
Right.
I have very limited, so I think, we're in constant communication with Jared, so if there's anything that he can't answer, then maybe he'll sort of send it our way.
All right, cool. Thank you very much, you two. I really appreciate it. And talk to you all later. Bye, everyone.
Cheers. Bye.